So probability is the chance that something is going to happen. So when we talk about the Dodgers have the best odds to win the World Series, this is the chance that something is going to happen. Trump winning the election by 4% is a chance that something's going to happen. 20% chance of rain tomorrow is the chance that something's going to happen. The game Cyberpunk being the biggest hit for the holidays by a 2-to-1 margin is the chance that something's going to happen. So all of these are probability situations of something going to happen. Probability is going to provide us a procedure calculate the chance. So one thing that probability does is to provide us a procedure to calculate the chance. Another thing that probability does is to provide certainty. And it provides a little bit of logic to uncertainty. Helps if I can spell a little bit, uncertainty. There is a formula that we use to calculate probability. We'll go ahead and get that out there. That formula used for probability, there is a basic formula. It is the number of ways something can happen compared to the total number of ways possible. The number of ways it can happen to the total number of ways possible. Most any probability situation boils down to this setup. How many ways can it happen compared to the total number of ways that it can happen? Sometimes it helps to look at probability visually. And when we look at it visually, we use what's called a probability number line. Probability stretches on this number line the value of 0 to 1. Probability can only have a value between 0 and 1. It can't be greater than 1, it can't be less than 0. When we talk about probability, when probability has a value of 0, that means that it is, or it has, an impossible chance of happening. It will not happen. It cannot happen. When a probability has a value of 1, that means it is certain to happen. It absolutely will happen. And so we have all these ranges in between. So it either will not happen, absolutely, or it absolutely will happen, from 0 to 1. Suppose it is exactly in the middle. That value would be 1/2, 0.5. If you are exactly in the middle, you are equally likely to occur. And so we want to picture, or we want to visualize, where is the certainty of an object going to be? Is it more likely to happen? Is it less likely to happen? And we look at the value of the probability, or we look at the situation, and we want to judge, is it more likely to happen or is it less likely to happen, based on being on that number line. So if we had a situation that said it was 4 out of 5 chance, that 4 out of 5 chance would fall near 1, which means it is more likely to happen. So any value that is nearer 1 is going to be more likely to happen. But if a value is near 0, what would we say to describe it? We would say that it is less likely to happen. That situation might be a 1 out of 6 chance. So this is our first skill, is not just to calculate what is the probability, but our first skill is to decide what is the likelihood of something to happen. Will it likely happen? Will it likely not happen? That is one of the first decisions that we have to make about a particular event. So we don't just jump into calculating the probability. One of the first things that we do is to look at whether it will likely happen, will it likely not happen, and then we might look at what is the actual probability and look at that to even help us decide, is it likely to happen, is it likely not to happen. So we use a combination. What is the probability? Or is it likely to happen? Is it likely not to happen? We use a combination of that information to help us look at the event overall. Now, as we talk about probability, there is some vocabulary that is used that you need to be familiar with, that you're going to come across as you hear probability, you hear people talk about probability. So you just want to be familiar with it. The first term is experiment. This is not the kind of experiment like in a chemistry lab where you go and might blow stuff up, but it is a type of experiment where you do trials or repeated procedures. That yield some kind of results. It might be as simple as tossing a coin. It might be a drug company performing experiments on volunteers to test a medicine, but it is some type of an experiment. The outcome would be, what is the possible result? If it was tossing the coin, the result would be it's either heads or it's tails. If it's that drug company, it's either success, the drug worked, or it's fail, the drug didn't work. The event would be where you have one or more outcomes of an experiment. One way to think of events is that it is a subset of the outcomes. So there's that term from sets, a subset of outcomes. It is a portion of the outcomes. And then we have sample space. Which is all the possible outcomes or results in the experiment. Sometimes it's not just simply tossing that coin one time. It might be tossing the coin 100 times, and you have to collect the data for all 100 tosses. The sample space would be what happened for all 100 tosses. Now I'm going to give you some examples that uses this vocabulary just so you can see it in use. As you look at your textbook and read in your textbook, there is a table, table 11 in your chapter. probability is chapter 11 in your textbook. But in your chapter, table 11 gives you some more examples than what we're going to go over in our lesson today. But that is a place to go to look at more examples if you need more. Okay, if we had the situation, toss a coin. To use our vocabulary, the experiment is tossing the coin. That is what the experiment is. The outcome would be what would happen when you toss the coin. You would either get a head or a tail when you toss the coin. Don't know why we're not focusing here. There we go. The event would be the toss. How do you get the outcome? What would have to happen to get the outcome? You would have to make a toss. Sample space. You would record the outcomes for 100 tosses. Which means you might have 60 heads and 40 tails. Let's look at another example situation using the vocabulary. We're rolling a die. Of course, remember, rolling a die is one. Dice means you're rolling a pair of dice, a pair die. So the experiment in this case is rolling the die. The outcome, when you roll a die, what are your choices when you roll a die? You can get a 1, a 2, a 3, a 4, a 5, or a 6. You don't have just 2 choices, you have 6 choices for your outcomes this time. The event is the roll. The sample space. is the results recorded for 120 rolls. So you came up with 31s, 42s, 10 threes, 0 fours, 25s, and 26s. And this would represent your sample space for 120 rolls. Do you need more examples for your vocabulary? Is that enough, or would you like more examples? What would you prefer? I'll leave that up to you. Would you like more examples, or?
One more example.
Pardon?
Can we see just one more example?
Okay, one more, and then we'll take a break from there, okay?
All right.
All right, one more example. Suppose you want to do cards or marbles in a bag. Which would you prefer? For your example, I'll do either.
Cards.
All right. All right, so for our experiment, we're going to draw a card. So we have a deck of cards, and we're going to draw one card from the deck. The outcome is going to be whichever card was selected. The event is drawing the card. The sample space would be the results for the selected cards after 10 draws. So it might be the same card each time, or it might be a different card each time. It may vary, but we're looking to find the sample. So chapter 11, there is a table that gives more examples that goes through this vocabulary and situations to help you see that information. Is that good? All right, let's take about a 10-minute break here. So we'll be back at 11:35 to start again. All right. Okay.